beginning to see how the mechanical aspects of the connectivity will work now. I want to continue to keep this electronics board in the frame as being the way I develop and test the software and the hardware electronics wise. But of course this is the physical grow box and it needs to be connected to all that stuff, but I don't want to be hunking this grow box around it screwed to the windowsill for one reason, so it needs to be disconnectable, and that's what this is about. This is one of the cables I've made up. As you probably guess, it's just a header strip hot glued down. It's going to connect, it is connected to this cable strip. The various signals will go into the grow box through this hole, which I'll patch. I'll put another one on here, and in this way signals can come and go, and I'll make up another one of these to complete the connectivity. It's far from ideal. If anyone knows of a, like a 30 pin socket solution that's better than this, then I'd be happy to hear from you. Anyway, we're making progress. Okay, so what have I done? I've taken this orange wire from the 12 volt supply coming from this back into the box, and it goes to, let me make sure you can see what I can see. Yes, it's unplugged. The positive of this SSR and the positive of this SSR. So the positive side of the signal lines are always high. The negative sides are going individually into wires 7 and 8 on this wire, which leaves for the processor board. Those wires arrive on the processor board in this line and this line. And so taking either of those lows should turn respectively the LED lamp and the heater on. So with the cover back on the box, we'll plug the unit in and we'll see. I've got an earth line here. I have double checked everything. Clearly you don't want to screw this up. But there's no electrical connection between the mains line and this line. This is earth. If I touch this line, the lamp should come on, and it does if you watch. And if I touch this line, the heater should come on. Now that's less obvious, but we can see on the box that that light's on. And if we go round to the heater itself, yeah, I can now confirm that it is getting hot. So we can control the heater and the lighting through the microcontroller as of now. I've decided that while I'm commissioning this thing, I'm going to monitor the temperature in here. There are some vents on this, and I know that it gets warm. These things are nowhere near their rated maximums, so nothing else should get warm. But I'm going to have this digital thermometer in here on the one wire interface. It's on line 5. I'm going to be monitoring that to make sure the temperatures don't rise, and of course I'll be watching everything carefully, touching everything for temperature and so on. Well, quite a bit of stress is over. I've now got the microcontroller itself controlling the LED. This is a port expander. This is GPIO 0 through a tens of K resistor to the gate of a MOSFET, which turns it on, which brings this signal, which comes from the SSR, down to ground. In the absence of such a signal, a much higher level resistor will pull that gate up, where it will turn this resistor off. Let's now see if it works. I've put some code in this program just to test it. Drive the LED light high, low, just so I can see what it's working. So now turn the thing on and watch for the light. There, you see it? Let's go again. On, off, on, off. So it all works. And if we look at the same thing happening in the mains box, turn it on, you see the LED on the SSR flashing, no sign of fire and brimstone or anything like that. So good. So the next step was to wire in this DHT 22 temperature and humidity sensor wiring goes out the case here, comes out the side, runs down and goes into the box. Turns out that one of the commissioning tests shows me that this lamp does get too hot when it's inside the box and the heater's running. It gets to about 50 degrees centigrade, which is too warm. So I'm going to follow the original plan, which is to stick a fan on there, and I'm going to start with a small one, see if that can keep it down. I've got a couple of options. I can turn the fan on and off under software control, but I don't want big thermal gradients, so I think what I'm going to do is connect it so that when the lamp's on, the fan's on, and I'll use the same signal wire that turns the lamp on to turn the fan on through a MOSFET, of course. Recap the existing circuit. The LED is driven by an LED driver which runs 18 to 36 volts to it in order to keep the current constant. It's a mains driven unit, and mains is delivered to it through this SSR, which takes a live and neutral feed and switches the live, sorry, the SSR takes the live and switches the live through the driver and to neutral under the influence of this control line, which must conduct a small current to turn an LED optocoupler on. This is connected permanently to 12 volts, but the ground side is sunk to ground only through the control of a MOSFET and microprocessor. So what I'm planning to do is put the fan on the LED, on the heatsink, and I'm going to connect its fan 12 volts to the permanent 12 volts on the box. This is dashed arrow, this is the box side of things, this is the electronics. And I'm going to connect the, I think, other side of the fan, the neutral side, to this. Now let me just check. This means that instead of a small sinking current through here, we've now got this fan's current coming through here as well. We probably need a protection diode there, and I need to check the power consumption of this fan. Well, good news. The MOSFET is a 2N 7000A, and its current, maximum drain current continuous, is 500 milliamps, and this fan drains 60, so we're in very good shape regarding that. So I think this arrangement, I'm a little bit nervous, but I think it's fine. I've had a change of heart on the fan. Firstly, it's quite annoying in this project, the physical aspects of making it. You need multi-line high current cables, and you end up with, you know, this coupled with this, and now we want a fan line. Do we find a cable that will work for all of them, or do we strap it together with cable ties? It's all a bit ugly. Anyway, then it occurs to me, this right here is a source of voltage between 18 and 36 volts. As I mentioned, it's coming from the LED driver. So why don't I just put a buck converter and regulator on there, like this one. Connect this to those two lines there. Connect this like that. Plug the fan in there. Plug the fan in there. And Bob's your uncle. When the light's on, the fan's on. And this is also means we don't need to worry about stinking up the SSR with spikes from the motor. So all in all, I'm going to go with this. This has got a maximum input voltage of 36 volts, but I've measured the working current on this, and when this is cold, it's at 26 volts, and when it gets hot, it's going to come down. So we're good. We've got plenty of margin there. So that's what I'm going to do. Connect the buck converter to that, and then plug it into the fan. Bob's your uncle, self-contained unit. Been thinking about the safety aspects of this box, primarily as I was about to to connect in the buck converter to the LED, and I realised that these connection points here are just ripe for being snapped off. As you raise and lower the LED, these flexes will eventually disconnect and might touch the chassis, which actually is no big deal unless they touch at the same time, but that might blow the driver, it might get hot, you know, it's just not something you want to do. So when I'm at the workshop on Saturday, I will make a proper cable grip here. I'll attach it here, I'll drill and tap 2 holes and put a plastic bar across there to grip this cable very firmly against here, so that these connections are not compromised or threatened by flexing in this wire. But for now, in test of concept for the fan, I'll lash it up. Here's the mechanical configuration. I've put the converter in some shrink wrap sleeving. I've used the plug to wedge it in the fin here, and it's hanging so it will blow sideways. This is going to operate this way up, blow sideways through the fins. This is just a prototype arrangement. Obviously it's not stable and not particularly robust, but it will tell me if the cooling fan is sufficient. I don't want to do a bang up job of fitting it to find that it's 3 times too small. And in terms of the electrical connectivity, I've teed the buck converter into the lines that feed the LED. Still no flex grip. As I mentioned, I'll get that done on Saturday. Let's take a quick look at the electronics. This is the heart of the system. It's an ESP8266 module 12. This is a 4-channel analog to digital interface, provides 16-bit resolution, and this measures things like the incoming light intensity, the voltage on a battery if there is one, and the soil moisture from the sensor there. This here is a port expander because the ESP8266 doesn't have many GPIO pins available, and I'm using some of those for the I2C bus, and I will be using 4 more of those for the SD card interface. Then we've got this is a power MOSFET, and here's another power MOSFET. This one operates the water pump to irrigate the system. I can't remember what this one does at the moment. I'll let you know soon. These lower level MOSFETs act to sync current from the solid state relays. These diodes, they are to protect from motors moving, generating back EMFs. There's a piezo crystal over here which just makes a noise. There's a temporary power supply here, and to program the chip I put this program the system I should say, I put this FTDI module there and an USB cable in here. This is the reset switch. This is the program mode. You hold this down when you turn the power on to put it into program mode. This is another power supply, power regulator, which steps down the 13 volts from the wall wart, which sits here, to well, a voltage I can choose, which operates this thing here, which is the stepper driver for the blind, which sits up here.